Welcome to our presentation on automotive clay model machining. First of all, a little bit about Tebis. We're an automotively focused software company dealing with all of your major OEMs and tier 1 suppliers for more than 35 years in the industry, with world-leading technology for quality, safety and efficiency. And today in our demonstration, I'm going to be looking at planning with virtual machines, importing predefined manufacturing processes to apply as a machining process. We're going to be using the stored cutter technology and the virtual machine in the software, in the Tebis software, to calculate the toolpaths and all of the technology applied to them, such as your machine head collision limits, etc., and the verification of the machine with the collision check using the virtual machine as well. So let's just talk a little bit about planning with virtual machines. Why do we do planning? I mean, this is a really important part because, first of all, we need to understand, well, does the job fit on the machine? This is really important. What we don't want to do is be programming for a machine where the part's too big and it can't literally physically fit in the machine. You know, also once the part is in the machine, are we going to have problems with many machine limits, rotational, linear limits, all of these things? And, you know, what sort of tooling are we going to be able to use? Do we need long tools, short tools? Are we going to have access to everywhere we need? And how do we even fixture our part on the table? The position of it, this is all really important and things that we need to understand. So intelligent manufacture using Tebis's template strategy technology. What's the importance of this? Well, the template technology has got automatic and variable selection of both data and cutter parameters from the software. And these benefit you from fast programming times to consistent qualities, giving you approved and standardized manufacturing processes, but also we can use ruled and freeform features with variables on cutting conditions, the way we want to cut things, and also we can apply these to your color tables for different fittings, whether if we take holes, for example, could it be a H7 tolerance hole or is it a threaded hole? We can use all of these things to guide our automation. But the good thing about here is that this isn't fixed. This is not a script routine. Everything that we do in Tebis is via toolpaths. Okay, so it's very easy to set up, it's very easy to maintain by the user. You don't have to be an expert in coding. And the beauty as well is that the software will not fall over if it comes across data that isn't there. The automation will not stop. If there's something that's not needed, it can just ride over it and ignore the toolpath that's not required. And, you know, we mentioned in our intelligent manufacture that we're using the cutting parameters from the tooling library. And this is really important because, you know, again, unique to Tebis is the amount of information we're storing in our cutting data. And it could be the difference between the cutting material of the tool itself, whether it be a solid carbide cutter, whether it be a high-performance cutter or inserted cutter, to the different machining groups, large machines, small machines, fast machines, old machines, new machines, etc. But also the type of operation we want to produce, whether it be roughing or finishing. And as you can see here, we can various ways of filtering down all of these processes, even to the processing material, the material we want to cut, whether it be cast iron, aluminium, clay. And you'll see we have all of our standard feed rates in here, which you'll expect from our spindle speeds, cut per tooth, and our standard step overs. But also, more importantly, we have all of the extra important parameters such as your plunge feed rates, your step over feed rates, your ramping feed rates and cornering feed rates, and also your recommended step overs with the AE values and step downs with the recommended AP values, all giving you consistent results, which means that when we change the cutter, the step overs and the feeds and speeds automatically update for you depending on which machine that you're cutting on as well and the material you're cutting. All this in combination as well with the recommended cooling parameters. And also in here, we're also able to replicate TrueForm tools. All of this is linked to our toolpath calculation, as I mentioned, from our tool magazines to the real tool build-up, from the cutter to the tool holder, any intermediate holders, etc. And it's all stored in a centralized tool library, which can be accessed and synchronized between multiple software clients of Tebis. Then we talk about our virtual machine technology and programming with it. Well, our virtual machine technology, again, is quite unique. Okay, this is something that Tebis has been doing for maybe 20 years now, and again, we've talked about earlier, we can use this in planning, but also we use all of these technologies in programming. And in here, you've got the advantage of having your full stock check for material removal. We're using all of the virtual magazines with your tool libraries, your tool magazines, etc. But importantly, when we're programming, we're using the technology parameters from the machine, the rotational limits from the head or the machine tables, and Tebis is not going to give you a toolpath which in reality cannot be produced. And then on your controllers, maybe there's some special macros and subroutines which can be incorporated in here. Also, things like all of your tool changes, if there's a machine head changes, all of this can be controlled within the software. Controlling of asymmetrical heads also could be important to you as well. In this case here, you can see the example on the screen. And finally, the multiple setup is a very important, unique part of Tebis's virtual machine technology, where we can have multiple parts programmed by multiple different people, but we can collect all of these parts together, set them up on the same machine bed, but optimize all of your tool changes and tilt directions to the most optimized toolpath. And then, the third part of our virtual machine technology would be the machine tool simulation and the toolpath validation, where we simulate not only the toolpaths, as you would expect, but also all of the macros on the machine, such as your tool changes, machine head changes, etc. And really important for us is that we can simulate all the connecting movements between the end of one toolpath and the start of another. Now, with all of these things, if we can also build in things like the look ahead on the controller, what are your rapid rates, etc., and build all of these into the virtual machine. And what this does is give you accurate calculation machine runtimes. So onwards with the demonstration now. And what you can see on the screen is a full data set of a car with the pedestals, how this would be located to the machine bed. And also what you can see from the data is that it's been color coded for us here. But additionally to this, we've broke it down into our structure tree, and we have a folder for our roof, our front screen, our front bumper, body side, etc. So we've broken it down into the structure tree too. Now either way would work, whether it be color coding or the way we've structured it here for our machining. But what you will see is that now applying a smart process template to this, CAM automation is not a difficult task for us now, it becomes more of an organizational task. So once you've done this organization, we should see where the car is now going to sit on the machine bed for our planning. So we do this now by loading first of all our virtual machine and the machine we want to put the car on in reality. In this case, we'll choose the FZ32 Zimmermann machine. And there you see the car has now been put into the machine environment. But what you will notice, it's probably not in the best position for me to machine this. It's also sitting a little bit low, and we need to adjust this in for our planning. So the next thing I'm going to do is look at the setup position. This has been automatically aligned to the center of the machine bed for me, but it still sits a little bit low, as you can see here, and we can just adjust this now by setting a Z value and just raising it up on the machine bed. Now, this is a position that I quite like to give me access all around the car, but let's just double check after this that we have the access that we require. So in my panel here, I can choose a tool from my tool library, and I choose a tool assembly in here from the list. And as you can see here, we have our tool. From the cutter, you can see the cutting edge, the full cutting length to the attachment into the tool holder. In addition to this, also, as we said in our PowerPoint presentation, we have all of the cutting parameters already in our list to apply to this, from our cutting material to our technology group, the type of cut we're going to use, and all of our speeds and feeds and technology parameters applied. So we'll choose this tool to start with. Now we're going to choose an element on the machine to say, okay, have I got access to this area? We can pick a piece of data in this case now. And what we see now is the tool aligned to this part of the job, and we can say, okay, this is good. I can see that we now have access to all of this area. This is good. What about the front of the car? Let's try. Select here, rotate the tool round, and again, you can see now what access we have around here. And if there was any adjustments I need to make, this is the time that I can do it in my machining setup. Okay. So now I'm happy with the machining setup and the position it is on the machine bed. The next thing I'm going to do is import a smart process template. And I can just do this in the structure tree by importing a set of templates. Could be any type of template here, but in this case we want to choose car templates for this type of model. And as I mentioned before, when we look at smart process templates in Tebis, we're just talking about a series of toolpaths. This is not script coding or anything like that, or some sort of plugin. All of these toolpaths are all fully flexible, yet automated at the same time. So if you do want to make adjustments in these, you can do. So the next thing for me to do now is to apply the data to these toolpaths, as you can see here on the screen. So I just set the parameter, I add the data to the toolpaths, and as you can see, the data now has been applied, and all that's left for me to do is calculate these. So here we go, we've just pressed the calculate button, and Tebis now will start calculating. Each toolpath will automatically select data from either the structure tree or the selected color, and it will apply the toolpath to it automatically now. So as you can see, we've already machined the top of the car. It's now machining the front bumper. And all of these with tilt directions automatically applied as well. And you can see now we're on the body side. And hopefully all you can see is that all we have done is organize the data on the car. We've planned where we want it on the machine. And now we apply a smart process template to check these things, to calculate the toolpaths. So again, program is a organizational task now, rather than a difficult programming task. So now the toolpaths have all been calculated. We can see here, if we go through one by one, there is our toolpath for the top of the car, our front bumper, even our front corner, our body side, etc., and the rear toolpaths. So now we've calculated all of the toolpaths, and now maybe we want to simulate this and check it. And remember, checking can be done automatically on here, but let's have a look at the simulation as well. So you see the car is now in its correct position. Let's apply the clamping devices on here too, so we can see the setup. And yeah, now we will have a look at the simulation itself, and we see the car is applied again in its correct position with all the toolpaths, and we can now see the simulation of the toolpath as well, should you wish to watch this. And remember that in the simulation, all collision checking for both the finished part and all of the residual stock can be checked from start to finish, all automatically as well in this process. So a full safe machining strategy. Let's have a look at another toolpath for the body side. Again, you can see the tool has been automatically aligned to the tilt direction I wish, and you can see here there's the simulation now of that toolpath. So in summary, Tebis is one integrated CAD, CAM, CAQ and MES solution. All is to give you seamless workflow, avoid any data transfer problems. So yeah, you're just using one software package with Tebis, not lots of different packages patched together. You're able to use the tooling library and the feature-based technology for full collision checking. You're linking your material cutting data, as you've seen today. You've got your tool magazine control as well, and the full form tool simulation. All of this adds to the intelligent manufacturer with our template strategy technology for standardized machining processes, fast programming times, giving you consistent quality. And as you've seen today, color table recognition as well. And our virtual machine technology. So with 20 years experience in this area, you can use the Tebis virtual machines at 3 stages of the process, which is very unique to us for planning, for programming, and for verification. And the virtual machine technology can be used in toolpath calculation for collision checking and optimization too. And also in the machine tool simulation for toolpath validation, checking your setup, your macro simulations, and maybe some asymmetrical head control, and giving you accurate machine time estimates. And don't forget as well, with that, we have the full stock tracking as well.